Hello, everyone, and good morning. Thanks for coming today to my talk. Today, we are going to talk about extending kotlinx.serialization functionality with arrow meta. Let me introduce myself. I am a senior software engineer with background in various languages, especially Kotlin and Scala, which I tried both on front-end and back-end. And currently, I'm living in Berlin with two cats who maybe will come join us on the Q&A session, so don't forget to join. So let's get started. So today we are going to talk about why we even had this idea, what was the use case, and why exactly arrow meta, what is that. We will try to implement a sample project, dive into details of this project, and of course, the showtime will be made for our result to check if we even got this right. So let's get started. The project that I have is just a backend with Ktor and arrow, so nothing really special or no front end. And for serialization purposes, we decided to go with Jackson, to be honest, mostly because it was kind of default solution for us. Well, it worked quite well. There was some kind of overhead and boilerplate. But the thing was our team decided to go with Kotlin first solutions. For example, for testing, we migrated from Makito Kotlin to Mockey to avoid the issues with null. So what could be better for Kotlin than kotlinx.serialization? Well, it was great from the standpoint that it's really Kotlin first, and there was no boilerplate with sealed class, which we had in our project, like a lot of them. But to be honest, there were also multiple downsides. For example, not a lot of serializers out of the box. There are, of course, serializers for common classes, but for the typical classes that JVM developer is using, for example, for instant, there were none, and you had to write one by yourself. While this is not a rocket science, when you have a lot of such typical JVM Java-based classes, it's a bit annoying. But the most important thing why we decided not to migrate to KotlinX serialization was lack of global naming strategy. So what exactly is a naming strategy? So in various services and various languages, you can define how would you typically call the variables. For example, upper snake case with upper case letters and underscores, or like typically in Kotlin with camel case, so the words are glued together without any underscores or dashes. So when you have a variety of multiple naming strategies across your projects in your department, you have to somehow match them. So for example, rename the uppercase username with an underscore to username in camel case. In Jackson, one will do something like this. You introduce an object mapper, a global one or a local one, and you decide inside the property naming strategies. In this example, it's an upper snake case. So in Kotlin, a serialization library, you cannot do something like that. For every property, you have to write a serial name annotation and explicitly rename it with the name that you want to have as input or output. In this case, the camel case is becoming an upper snake case. So that's not really a problem, but to be honest, When you have enormous data classes with a lot of properties, you have to write a lot of them. And sometimes even not every variable will be used, so it's kind of hard to read. But taking a look at that, we can say that there is a clear pattern. So the properties are stored in data class, which are marked as serializable, and every property is marked with serial name and remapping of its name. So sounds like we could automate it. That was my thought. So, and which is why I was thinking, why not experiment with arrow meta? There are multiple ways to solve this task. For example, there is cat and KSP, but we had some libraries from Arrow, which is why I wanted to try exactly this library. So Arrow Meta is a meta programming library that cooperates with Kotlin compiler in all of its phases, bringing its full power to the community. That's why they claim on their website. And using this library, you can write compiler plugins, transformation, linters, so everything that you lack in Kotlin. Let me show you the GIF from the website about the strategy of this library. So first of all, you're typing some code. Then your meta intercepts your code and rewrites it. After that, the code will compiled and processed. And then it will be run as usual. So, oops, sorry, for this should be the last slide. So today we are going to try a sample project. So a tiny disclaimer, this won't be the most efficient way to implement that, and the case is pretty much specific. Also, it's not so configurable for the educational process, for the educational purposes, but you can follow these slides also on GitHub. So let's get started. Today, we are going to build a zoo. A zoo has various animals, well, actually only dogs and cats in our situation, that are coming from various sources. So imagine a third-party services, and the standard of documentation of those animals may vary. So imagine you're collecting JSONs from various services with various naming policies. For example, upper snake case, kebab case, or whatever. A typical cat will be described with a data class and its properties, so like name, age, and owner name. But today we want to interact. With a service that remaps camel case and accepts only the snake case. So how do we set up a project? The simplest way to try a project will be going to Arrow examples repository and take a look on how to set a project with two models. In my case, I did exactly the same, and in my project, I had create plugin model and use plugin. In the create plugin, we developed a plugin itself and then use, so the zoo with cats and dogs. So the most important steps that you should do in create plugin, you have to add dependencies on Arrow compiler plugin and add a typical jar wrapper. In use plugin, you have to add a dependent task. So when you compile your zoo, especially use plugin, you have to catch the data from the create plugin part. The first step is create an extension function. So on the meta class, you define your plugin. So let's start with to do as usual, and then add its name. And in meta, we will do the exact logic of our plugin. Then you have to register your plugin. So you have to list it in the intercept function, and also, not noted on the slides, add to the component register in the meta.inf folder. So let's think about the logic itself. So there are multiple phases when we can intercept the compilation. So for example, on the class declaration, so exactly the class signature, its insights or whatever, on the or finally section in the try catch finally block, in destruction declaration and class body, so the body itself, and in some others. But today sounds like our case is suited best with class declaration, since we want to get the class which is annotated and its properties. So let's go with class declaration stage. Where we are doing exactly what we described before that. So we are looking for classes that are annotated with serializable annotation. Now let's think how would we transform our properties. So when we get parameters, we want to add the annotation and make some remapping from one naming strategy to another. What's important here, as you can see, there is a full qualifier of the annotation itself, because we are operating only inside the class declaration, and we cannot add right now some kind of import on the top level, which is why we are using the full qualifier. So then we introduce some function to snake case, so we are splitting the variables by, for example, uppercase letter. It may be a bit more tricky, for example, when you are splitting abbreviations, but you can do what suits your best, and then add underscores between words. So yeah, this should work. So now when we have the class declaration and remapping, we should glue them back together. So it's like a puzzle. You get the annotations, kind name, the transformed parameters, and then you just build them together in a string. And then define the transformation. So you just say, replace the old declaration with the new one. So my question is, what if we already have the fields that are annotated with this serial name annotation? So for this scenario, you may write some kind of check to avoid these situations like this. So for example, you can write the annotation check with regex and then add it to your replace block, so your annotation won't be added twice. Cool. Let's check what we have in our project in IDEA. So let me switch to the presentation mode. One second. Sorry, apologies for the delay. Oh, yeah.
It's a view and representation mode. A view appearance.
View appearance. Oh, thank you. So this is our main class, our serializable cat, our serializable dog, and the main function. Let's take a look at the plugin first. So this is exactly what we've got. So we have our plugin with a get method, with its name, with its class declaration, so the level where we are going to do our transformations. So our condition when we don't add the new annotation, parameters list, the transformation, and exactly the replace for this transformation. So let's get back to our main class. Here we are just encoding our objects to string. There is no serial name noted here, so one would expect owner name written in camel case, but when we run it, we are getting the output as snake case. So this works, which is great. So the next steps for this project will be add configurable serial name strategies and extend it for bigger projects, because currently it's made for tiny data classes. You can find more information on the official Arrow pages, and also you can read it in my technical blog on how it's made if you prefer reading than listening to the talks. Yeah, thank you for coming for my talk, and I'm waiting for your questions